Alright, in this video we're going to show you how to batch download data from a LIMS database into the COD system. So here we are, we've got the demo experiment open, and I notice that we still have a Janus DataLoaders up, so let's get rid of those guys. We'll just open that up and kill it. All right, now let's bring in the includes files folder, and we want includes lore data loaders. There we are. Double click. We'll compile it. And hide it. Don't need these guys anymore. And so we can load calcium carbonate, GRA, MAD, susceptibility, gamma ray. There's a P-wave logger, the P-wave bayonet, another P-wave measurement. This is on the half core. RSC, that's the color, and magnetics. Whoops, cancel. All right. So now we have the menus, now we need some data. So let's go over to the LIMS report page. We'll go to physical properties. Let's take a look at GRA. We want standard. We'll pick an expedition. 321, there it is. We'll pick a site, U1338, and let's take hole A. There we go. One more thing you need to do when you're doing MS and GRA, there's a fast track measurement that's made right after the core is recovered, before it's had time to equilibrate for temperature. And those measurements are done every 5 centimeters or so. That's as opposed to the standard scan after the cores are equilibrated that is done at about 2.5 centimeters, and is, if you look up here, it's the WR-MSL that we want. The ST is the fast track, the WR is the standard. We got all this set up. Let's go to view data. You can see some of the data listed. You can see we got 1338A, so that's all good. Now, LIMS does not display all of the data in a single page, a single web page. So we have to, instead of copying and pasting like we do for Janus, we're going to have to download the data into a file, and we want tabular data. If you use display to CSV, you will get only these data that are in this display, and you can see this guy only goes to core 4. There are 40 cores or something like that at site A. So we want to download tabular data like that. You should see this thing and some stuff there. So these guys are kind of slow, and rather than waste your time, I've actually downloaded GRA for holes A, B, and C already. There they are. So we're going to go up to the lore loaders, and we want GRA batch load. Now notice this is a batch. That means we're going to do all 3 of these at once. Well, it's going to ask you what you're going to use for core catcher. It's 9. We're going to select the data folder. Now it warns you that it's going to try to process all of the .csv files in the selected folder, and that you will get an error if you go after non-GRA files. You want to change it. Let's say yes. We want to choose this guy, which is core data. Move this guy over a little bit. And there we go. If you go here, You'll see there's A, B, and C GRA data. You can also go up to COD data if you like and say make data table. And we'll just choose one of these, GRA B. And here you are. Here's your data. And all the way down to core 45. All right, now we already have offsets because this is something that's been worked on, a site that's been worked on quite a bit. So why don't we form the CCSF, the offset data, right away. So we'll go up to COD data, processing, and we're going to calculate the CCSF wave. So let's start with A, GRA. The input depth is CSFA. If you forgot, it's over there. Can't quite see it, unfortunately, with this open, but CSFA is what it is. And the output data we want to be CCSF. So I would use MBSF up here and MCD for the older sites before they came up with the naming protocol for depth types. And we'll continue. Now if we go to GRA, A, now there is a CCSF as well as a CSFA. And finally, just for the heck of it, we just did A for CCSF, and we would just copy out this line, do B, copy them out again, and do C. Okay, and if we want to plot one of these on top of data, we'll go up here to data, plotting. Now we want to append data. We'll do 1338A. We're going to append it. It's GRA. In this image, the A images are 0 to 33% of the Y axis. We want the axis right and CCSF. And there we go. These are noisy data. You'll get a chance to find out how to quickly despike those data in another video. But let's, for the moment, see, 1.15 to, let's say, 1.5. Here I've changed the axis, and you can see that the GRA align pretty well with the color changes at this particular core. So it's a good way to define different layers. And that's it for now.